So today we are talking about Unity's camera system. Before I get into that, I would like to again bring this up. If you have any questions or comments or concerns or just want to say hi, you can reach us all via Twitter at Unity3D, at UnityMikeGeig, which is me, at Will Goldstone, and at the Ant Ranch. You can reach us all and have a conversation or whatever. You can also reach us on Facebook and through the unity3d.com website and all sorts of different ways. I think we're on Google Plus and social media everywhere. Okay, so that being said, we are talking today about cameras, okay? And they seem like a fairly basic thing, right? Every scene sort of has one, and no one ever really thinks about it. But there's a lot we can do with cameras in Unity, and furthermore, there is some really crazy effects that a lot of people don't know can be achieved with the Unity camera system. And so we're going to look at some of these things today. And I know a lot of people are saying, you know, man, we want advanced stuff, and trust me, it's coming. So if you're one of the many people who have been commenting, we want more advanced videos, they're coming. We're building up to it. But more than likely, whoever's viewing today didn't know all of this stuff about cameras. So even though this might be quote unquote a beginner video, I assure you I'm going to show you a lot of cool stuff, and you're likely to pick up something new. Yeah. Okay. So cameras in Unity are treated very much like cameras in real life. Actually, someone in chat made a joke about, well, they need their DSLR, their phone camera, or whatever. And realistically, the way we treat cameras in Unity, perspective cameras, is very much like how those cameras function. Okay, and so we can achieve a lot of similar effects with the Unity camera system that we can achieve with some other like real life cameras and stuff like that. We're going to look at those. So basically, every scene in Unity has to have a camera. Without a camera, we can't see anything. The camera represents our eyes. It's the viewer's eyes into the world. And as a matter of fact, every time we create a new scene, like I've done here, I've created a new scene, every scene starts with a camera. It's the only thing in the scene is just a camera. And using that camera, we sort of build our world, right? And the first few times you make a game, you might leave the camera right where it's at and just build the whole world around it. Never touch the camera, right? But we can move the camera just like any other game object. We can move it, we can rotate it, all those things. When I click on the camera, what we can see is we can see the projection lines of the camera. Anything that exists within this projection, right, will be seen, and everything that exists outside of that projection will not be seen. All right, and you can see it starts at the camera, and you can see where it kind of ends there. This big projection camera. All right. So yeah, so this camera we can use and model and turn and whatnot, manipulate just like any other game object. All right, and just remember always that no matter how technical cameras get, they're still basically just our view into the world. However we want that to be represented, however, whatever effects or shaders or anything we want to apply to that, it's just how we're going to see the game, and every game has to have one. Now, the camera itself is just a component, okay? So I talked before about how everything is basically game objects and then you stack components on top of them. So that being said, knowing that the camera is just a component means that I can put a camera on anything, all right? I can create a cube. All right, if I were to say, come over here, create a cube, I could put a camera component on top of this cube, if for whatever reason I really wanted to. So the camera components can be on anything. And as a matter of fact, let me just go ahead and do that. Talking about it. Let's see here. I can never remember. There we go. It's under rendering. So with the cube selected, I went to component rendering camera. And now my cube, while being a cube, also is a camera. All right, and it can't see anything, obviously. This camera can see the cube, and this camera can't see anything. So yeah, so we can put a camera on pretty much anything. Okay, let me get rid of this. Now, the camera that starts in the game or it starts in the scene, and a camera that you might create by going to game object, create a other camera, has more than just the camera component. It also has these three items right here. The first is the GUI layer, then we have a flare layer, and then an audio listener. The GUI layer is what will draw the graphical user interface if we have one. By unchecking this, it won't see any on GUI commands, won't see any GUI stuff that we create. The flare layer, so we can see lens flares, all right, if we have those on our lights. By turning that off, we don't see those. And then the audio listener. Now, the audio listener is a special component. There can only be one in a scene, all right, for each player, basically. There's ways to separate it out, but there can only be one, because just like you have only one set of ears, there can only be one way for all audio to be calculated, right? So unlike multiple cameras, which we can layer and point at different things, audio doesn't really work that way, all right? So we can only have one audio listener, and if we have multiple cameras, only one of those cameras can be the audio listener. So just keep that in mind. If you get a warning that says, warning, there are two audio listeners in your scene, you can only have one, what it means is that you have two cameras. You just need to uncheck that on one of them. Only one of those can have that component checked or have that component at all, or you're going to get a warning. The whole game will still work, but your audio is going to be funky. Basically, just make sure you have one. All right. So yeah, so again, cameras, just components, and the camera object itself has a few more components than just the camera component. Now, before we start talking about all of the different pieces of the camera itself, I want to talk a little bit about space, okay? And so I'm sure a lot of us are familiar with 2D versus 3D, right? The two-dimensional space, X, Y, Z form, or I'm sorry, just X and Y format, just width and height, no depth. A lot of 2D games started 2D, right? Just without that third dimension. And then obviously 3D space adds the Z, adds the dimension, things like that. So a couple new spaces we're going to talk about as they pertain to cameras, okay? So we still have the world the world space, and the world space is your X, Y, and Z coordinates. It's how objects move around. It is your coordinate system. That's your world space. And whether you're using a 3D or a 2D game, right, whether you're making a 3D or 2D game, you still have this world space, which is how the objects exist inside your game. That being said, we also have something that is called a screen space, and I have a little cheap little infographic here that I created. Now, hopefully that'll pop up there on the screen. But basically, we have this idea of screen space. And screen space is how the world pertains to your monitor, all right? To whatever, your TV, if it's a console game or whatever. Your viewing device, all right, is represented in this screen space. So you can see in the rectangle at the top there, we have screen space. And with screen space, it's a 2D space with an X and Y component, and the upper left-hand corner is the origin. All right, we call this a fourth quarter or fourth quadrant Cartesian system, but basically the upper left-hand corner is 0, 0, and the lower right-hand corner is whatever the resolution of your screen is. So I have 1280 by 1024. That was just an example. If you're running at like 1600 by 900 or 1920 by 1080 or whatever, those would be the numbers that are there. All right. So based on whatever your screen size, that is your screen space. So, you know, if I wanted to be right in the dead center of the screen, I would aim my screen space at, oh man, I shouldn't have started saying that because now I'm going to have to do math. 640 by, what is that, 512? 640 by 512 should be halfway through a 1280 by 1024 screen. Yeah, so that should put you right in the center. If I did math wrong, don't make fun of me. I'm sorry. I might have been right. I'm not really sure. But that's our screen space, so we can sort of aim for that. All right. Then we have something called viewport space. And viewport space is useful for how we combine our cameras together. And a viewport is a normalized screen. And what that means is that you won't go from like 0 to 280. You'll go from 0 to 1. And you don't, you know, with height, it's also 0 to 1. So your upper left-hand corner is 0, 0. Your lower right-hand corner is just 1, 1. Okay, no matter how big your screen is or how small your screen is or how rectangular or squarish or whatever, it's always 0 to 1. It's a normalized screen, all right? So 0.5 will always be halfway through a viewport space, All right. So if I wanted the dead center of a viewport, I would say 0 or 0.5, 0.5. That's the dead center no matter what. Okay. And we'll talk about where these are useful, but I just want you to be aware of those, so that when we get in there and we start working, you'll be able to just kind of hit the ground running, and you won't have to go through this stuff then. Okay. So that's our viewport and our screen space and a little jaunt about world space. So now let's talk about the properties of the camera, okay? And I have my scene with just my camera here, and we're going to be opening up another scene here soon that'll give us kind of a more idea of stuff. As a matter of fact, let me just open that now. So I have this, basically, I'm not going to say that. I have the terrain from last time here. Alright, I have this terrain from last time without all the environmental effects. We don't have the lake and we don't have the trees or anything like that. But I wanted something to be a little bit more visual so that we can get kind of an idea of different perspectives and things like that. So what I'm going to do is I'm going to create myself a camera, because in this scene we only had the first person controller. We didn't have a main camera. So I'm going to go to Game Object, Create Other Camera, and I've obviously deleted the first person controller, which is why it's not there. Which gives me this camera here, and I'm going to go ahead and rotate it so we face our terrain, and I'm going to just move it around here a bit. So we have our scene. Taking my sweet old time here. Alright, so we have a camera and we can see our screen here, and that's another thing, by the way. If you click on the camera and you look down here in the lower right, you can see what the camera sees. You don't necessarily have to go over to game mode to see what the camera's seeing. Alright, so you can just click scene and there it is. Alright. Okay, so let's go through some of these properties of the camera component. So the very first thing we have here is this clear flags. Alright? And the clear flags can often confuse some people. So let's talk about what this does. Alright? Right now, clear flags is set to skybox, and it's always set to skybox by default. And what that means is anything the camera doesn't see. So if I was, I don't know, a ray or projected light or just pretend beam from this camera, and I was flying out here and I was going over all of the mountains, right? All this space that's here that's blue, all right? That isn't hitting anything, right? That those rays or however it finds the scene, it's not colliding with any game object. It's not colliding with the terrain or a sphere or cube or anything like that. So it's just kind of going off into nowhere, right? So if it doesn't hit anything, what do we put there, right? If there's nothing to see, what goes there? Well, with this flag, with the skybox flag, if we have a skybox, all right, that's what's drawn. All right, that's how we know where to draw the skybox. If you don't hit, basically it's like telling the camera, hey, if you don't see anything, put the skybox there. All right, and so that's what our skybox is. Now we don't have a skybox in this scene, but if we did, we'd see it. The next option is solid color, and that's to say, hey, I don't want to see the skybox. I want to see some solid color. And by the way, if you don't have a skybox, the solid color gets chosen as your backup. And you can see here we have this blue, but I can change that. Right, I can make that any color I want. It just so happens to be blue is the default. Let me go back to that. Blue is the default because that is kind of skyish, right? So that's our default. We also have depth only, which means if the ray doesn't hit anything, right? If we're not hitting a mountain or a cube or anything like that, then just don't draw anything. All right. Now that's not a good setting if you only have one camera. Basically, if you only have one camera in your scene, stay away from that. Just leave it on the skybox, right? I'll talk about when we will use that. We won't use that right now, okay? And the final one is don't clear. And don't clear is, again, something you pretty much should just never use, all right? What don't clear basically says is that every frame, when the scene is drawn, all right, the next frame, don't delete what was there before. Alright, so basically what happens is the camera will render something that it sees, and then the next frame it will delete everything it saw and render something new, right? Well, with don't clear, it doesn't delete what it saw. So if I were to move an object left to right, you would see that object every single frame stay. So you'd get the streak going, right? And everything will just sort of streak and blend together, and it gets all weird. The only reason that option exists is because you can use that to achieve some effects, and you can use it with specialized shaders and things like that. You shouldn't use it unless you absolutely know what you're using it for. All right, it's not one of those things that you can just accidentally find a use for. You have to have a use intended, or else it's not going to work. Okay, so the very next thing is background, and again, I showed you background is just the background color that when it doesn't see anything, that's what it sees. We have this thing called culling mask, and culling mask is how you can turn things on and off. All right, so if I were to uncheck or just click on nothing, all right, the camera won't see anything, and if I click everything, the camera will see everything. We can get very specific with this, and we're going to a little bit later. We're going to get kind of granular with it and really kind of do some neat stuff with the culling mask. We have our projection, and we have two types. We have perspective and orthographic, and perspective is a 3D viewing mode. If I go to orthographic, you can see down here what happens. The world flattens out. And we'll talk more about orthographic later. I don't want to get into that right now, but we have this orthographic. And then we have our field of view, and the field of view basically determines how wide of an angle our lens has, all right, the lens in our camera. If you know anything about photography, you might understand some stuff about focal length and field of view and lenses and cameras. If you don't, I'm going to show you. I don't want to spend a lot of time on it right now, but I'll show you kind of the effect that has, all right? Next we have the clipping planes. And the clipping planes, clipping is basically how close or how far away something has to be before you can't see it anymore, before it's not rendered, before it clips. So if you ever say, man, someone clipped into a wall in a video game, it means they got so close to the wall they stopped being drawn, or they went into the wall, or whatever. So those are our clipping planes. And so I'll show you here. You can take a look down here. As a matter of fact, I could probably go here and do this. If I increase my near clipping plane, you can see things that are now close to me aren't drawn. All right, so I can make it so only far away things are drawn, but I'll leave it at the default 0.03. Yeah, somewhere close to there. Now the far plane is the exact opposite. It determines how far away an object is before it's drawn. So this could take a while. Let me just click in here and 100. There we go. So you can see we can determine how far away an object is before it stops being drawn. So an object that is only 48.7 units away will no longer be drawn. All right. This is great for low performance computers. Right. So if you're making a game that's targeting a device that doesn't have a lot of power, right, you don't want to be drawing things that are 1,000 units away. It's going to have a really hard time doing that. So you might want to bring your clipping plane to be closer. Right? You don't want to be that far away with it. All right. So, one moment. Okay, sorry about that. Okay, so let me bring this plane back to 1,000. So, that's 100. There we go. So that clipping plane, that's what that controls. The near and far clipping. Basically, however, you wanna go about that. All right. Now, real quick, I'm just going to take a break. I'm not seeing anyone talking in the chat. You might just be all captivated by my voice, but if there's a problem with chat, I'd like to know. So if anyone would mind just telling me in chat that chat is still working. Otherwise, I'm going to assume that maybe something broke with that. Oh, okay. Chat is working. Everyone was just adequately captivated. Fantastic. That's what I like to hear. Okay, fantastic. Everyone is captivated. Great. Appreciate that. So, oh, I lost my train of thought. Great. Okay, so we talked about the near, far clipping planes. All right, fantastic. So we have our near, far clipping planes, and that just basically controls, again, what's shown and what's not. So it's used for performance, okay? All right, so then we have this normalized viewport rect. And basically, this is how we control the viewport. We're not going to talk about this right yet. We'll talk about this later when we start doing things like split screening and picture-in-picture. But for now, we're going to leave this completely alone. Then we have our depth. And as a matter of fact, this camera came in with a depth of 0. But a main camera will come in with a depth of -1. So I'm going to pretend that this is the main camera of a scene. Even though I deleted my original main camera, we're going to pretend this one was the original main camera. There's no difference. It still has all the same stuff. But the original main camera comes in with a couple presets that this one does not, because it's not the original main camera. And one of those is that it has a depth of -1. Depth we'll cover more in depth here soon, but basically depth allows us to control what order the cameras are rendered to the screen. So using depth, we can layer cameras on top of each other, and that's how we achieve some things like split screening, picture-in-picture, custom GUIs, things like that. We have this rendering path, and the rendering path basically is how we do our rendering. I'm not going to get into these settings because A, they're really more in depth than you will need right now, and B, because I don't really know them all that well. I generally just leave it to player settings, and if I ever need to change it, I change it once in the player settings and I forget about it. So it's not anything I could really walk you through in great depth because it's not anything I've ever really had to use. Our target texture is actually really, really awesome. This here is so cool. I hope we have time to cover it today. One of the last things I want to talk about is how we're going to use this target texture. It's a pro-only feature, so that's why I put it towards the end. But if we have time, I'm going to show you some cool stuff. But basically, right now the camera renders to the screen. But we can tell it, instead of rendering to the screen, to render to a texture. And then we can put that texture on something. So everything the camera sees will be projected on that object. And it gets really, really cool. And we can do things like Jumbotron screens. And we can do things like Predator-style transparency, like from the movie Predator where he goes all transparent, right? We can do that to game objects and stuff. So we can actually do some really cool stuff with that. And actually, that's the reason Pro Water looks so much better than basic water, is because Pro Water can use rendered textures, so that the camera can project the sky on the water, and that's how it achieves that effect, and that's why it's a Pro only thing, because this target texture is a Pro only thing. But I'll still show you. And then we have HDR, hyperdynamic range. Basically, again, another photography term, though it might also exist in film. I'm only familiar with it from photography, which basically allows us to change exposures and have images come out like really bold and strong and things like that. It only works for the very specific camera setup and very specific texture types. As a matter of fact, if I click it on here, I'm going to get a warning that it won't work. It's going to say HDR multi-sample anti-aliasing and forward rendering path is not supported. This camera will render without HDR buffers, disable anti-aliasing in the quality settings if you want to use HDR. So basically, you have to have a very specific setup to use that. I'm going to clear that message. And so that's what it is, but we're not really going to get into how to use it because it just doesn't. It's not something that we're going to use often. I've never used it. It can be used to great effect. If you know a lot about 3D projections and stuff like that, which I do not, so I generally just skip it. All right. So we have all of these properties of the camera, and most of them are pretty specific, pretty basic, right? So let's look at a couple that you'll find more useful than not. And so the first is this. What we're going to look at is we're going to look at our projection, all right? Because this is something that it's one of two ways, and you're going to use it a ton. All right. So let me get here a cube. Game object, create other cube. Let's take a cube and let's just put it. Let's see, what's my camera at? I hate these when it does decimal. So let's get 56, 33, 87. There we go. And we'll put this one at 56, 83? No. 56, 33. 56, 33, and that one was 87, so we'll put this one at 80. All right, so we should be seeing that cube pretty straight on. And actually, let me just bring it a little bit closer. Okay, so we have a cube, all right? And the cube is great. I'm actually going to lower the cube down a little bit so we see something kind of akin to that. So what we have now is we have a 60 for our field of view, all right? What that basically means, that's just our default, and you can see if we come into the game, this is kind of what we see. And you can see the perspection, right? Or projection, perspective, sorry about that. Where we can see the lines kind of angle inward like it would look in real life, right? If you've ever done any photography, you know that you can have things called wide-angle lenses. And wide-angle lenses allow you to see more of the world at one time. The problem with wide-angle lenses is they cause a lot of distortion to close objects, and they make the background look really, really, really small. All right. So if I were to come back here to my scene and take the same camera, take my field of view and go real wide with it, real wide. Okay. By dragging it to the right, increasing my field of view, bring my camera forward a little bit, and now we can take a look. And So we've actually got closer to everything. We've moved our camera closer to all the stuff in our scene, yet look how far away it looks, right? And look at how warped our cube is, okay? So we can achieve these wide-angle lens effects to create really wonky graphics if we wanted to, where objects seem like really, really far away, then all of a sudden they get really, really close really fast, and things like that. So we can use our field of view to do that. Now, this distorts greatly. What if even at the basic 60, it's too distorted, and I want it even less distorted than that? Well, what I can do is, by decreasing my field of view, I'm effectively decreasing my angle, right? And then bring my stuff way back. Now, having a decreased field of view does the exact opposite. Not only does it reduce distortion significantly, right? You'll notice how the perspective lines are not nearly as steep and not nearly as deep as before, but they also make the background look huge. It does what we call flatten out the picture, right? It brings the background way up close, so the object doesn't look as deep. All right, so compare the two. All right, not deep, super deep, right? And nothing in my scene is moving. I'm just moving my field of view. All right, and so we can create these really cool effects this way. It's all about what you need. All right, super zoomed out. It's all about what you need and whatever will suit your purposes. But 60 is the default. All right, and you can kind of salt to taste from there. But basically, yeah, 60 is your default, and you can super zoom with it, or you can get really far away. And that's another thing too that I'm going to mention while I'm here, is that by changing my field of view, I am effectively able to zoom in and out without moving anything. Nothing is getting closer or getting further away, but I can zoom in, right? Look how close I can see that texture, right? I can get super close. It's like having a zoom lens, all right, or a zoom out, okay? Nothing is able to move, or nothing is moving, but I'm still able to do all this really neat stuff. So change that back to 60. Okay, so that's my perspective camera. So if that's perspective, let's talk a little bit about orthographic. And let me just kind of bring these up a little bit. So that's a perspective camera. I'm going to choose orthographic now. Now, orthographic is a camera that is treated as being infinitely far away. So you remember in perspective here, when I had a really narrow field of view and my lines start to look very parallel. I mean, they're still not parallel. They still kind of cone out, right? But they're starting to get closer and closer to parallel. Well, an orthographic camera is treated as if it is so far away that those lines are in fact parallel, right? Kind of how like a directional light or the sun sends so much light to Earth in parallel lines. They're not really parallel, but they're so close to being parallel that you can't even tell. A question from the Lulness, which is a great name, by the way. This is horizontal field of view. Well, it's both horizontal and vertical field of view. It treats them all the same. I'm not sure if you can do one without the other. I'm sure they would cause quite a bit of distortion that way. So it is just all field of view, not necessarily just horizontal field of view. But, okay, so I've come back here. Now I've chosen orthographic camera with a size of 100, 100 being the default. If I come to my game, this is what I see. Right? There's no distortion, literally no distortion. Everything is flat, right? Because the lines of the camera are treated as being completely parallel, right? It's like having a perspective camera that is so very far away. And you might be like, oh, this is way too far away. Let me make it bigger. But wait a minute. It's not getting bigger, is it? The only thing you're seeing down here is my field of view. Is my near clipping plane is clipping some of the stuff out. But it's not getting any bigger, is it? It's not, because we ignore the z-axis, right? Everything is horizontal, or everything is parallel. So we don't have moving things in and out, right? Is irrelevant. Will not change anything. So how we do that, zoom in, is we change the size of the parallel lines. So by bringing this number down, you can see we're zooming in. All right, and so right here is where we can see the cube. Okay, and that's what we can see. Again, the background is really close to the foreground because, oh, I'm sorry, I saw comment about thewalkingdead.com and I thought we had a spammer, but it's someone just talking about a game jam. Sorry about that. I thought for a second we had a spammer, and I was like, oh man. Okay, so yeah, basically it flattens out, makes the background really big and really close to the foreground. Generally, with an orthographic camera, we make 2D games, so there is no background and foreground depth that matters because we're not dealing with depth at all. Everything is flat, right? Orthographic cameras are great for that. If this was supposed to be using some form of projection, it would be not very good because of just how flat and close everything looks. And if you, well, let's see here. Let me split this off here. Oops. That's what I'm going to do. So this is our camera, what our camera's seeing. Notice how if I move the cube at all, no change. None whatsoever. As a matter of fact, if I move it even into the mountain, hopefully the mountain is big enough back here to move into. Yep, perfect. Ooh, I clicked off screen. It just disappears when it comes to the mountain, but that's it. That's the only effect it has. All right? And that's because the orthographic camera does not care about depth, only what is right on top of the other. All right? So I'll bring my cube back here. There we go. Okay, and let me bring this back in. Okay, so that's our orthographic camera. And the way we zoom in is by... we can also go negative with it, by the way. A negative size flips everything. I'm not saying you would ever want to do that, but you certainly could. But anyway, so it starts at 100, and that's how we kind of zoom in and out with the size there. And again, we use that for 2D games. Okay. Let me come back to perspective because orthographic confuses me. All right, back in perspective. Fantastic. So yeah, so we have these types of projection, and we can kind of mess around with that stuff. All right. So that's all well and good. We've got our camera, and we can do some wacky stuff with it and whatever. The best, or one of the coolest things in my opinion, is the ability to use multiple cameras. And multiple cameras allow us to do all sorts of different stuff, right? So let's consider this. What I'm going to do is, I already have a directional light in the scene. Fantastic. I'm going to move this camera kind of to the side, just like this. So we can see this, because it's over to the side. And I can create a new camera by just going to Game Object, Create Other, and then Camera. But what I'm going to do instead is I'm just going to right-click on the camera I already have, and I'm going to duplicate that. So we have a new camera. And this one I'm just going to drag over here. Alright? So we have Camera 1 and Camera 2. Fantastic. Now what I'm going to do is I'm going to run this scene. And, first off, we're going to see one thing I told you about. We're going to see there are 2 audio listeners in the scene. Please ensure that there's always exactly 1 audio listener. So that's kind of what I'd mentioned before, and there's that message. So I wasn't lying to you, there it is. But another interesting thing that we see is that we only see the 1 camera, right? I mean, if you think about it, we had 2 cameras. One should show the block on the right, the other should show the block on the left. However, when we run it, we only see the block on the left. All right, and so the question, and let me remove this audio listener. The question becomes why? Why did we see one versus the other? And it has to do with order and depth. So we have 2 cameras, okay? And the 2 cameras are identical. I just duplicated one and moved it. So all of their properties and everything about them is exactly the same, including this depth. This depth right here is -1, the same depth a main camera has. And what that depth does is it controls what order the cameras are drawn, all right? So we start at -1, and then we go to 0, and then 1, and then 2, and then all the way up. So what is effectively happening is, since this was the first camera in this scene at depth -1, it's drawn first. And this is actually drawn to the screen. What this camera can see is drawn, okay? It actually is drawn. And then this camera is drawn, because it's also at depth -1, and it's the second camera of that depth on the scene. The problem, then, is that this camera is completely overriding everything about this camera. All right? It's like if you paint a picture on a piece of paper, wait for the paint to dry, and then paint another picture. Well, the first one goes away, doesn't it? Because the second one was painted on top of it, right? And so that's effectively what we have here, is we have the second camera is being painted on top of the first camera, and so we no longer see the second I'm sorry, the second camera is painted on top of the first camera, so we no longer see the first camera, anything that the first camera could see. All right, and that certainly is a problem. And luckily for us, it's a problem that has a lot of different solutions, but it is a problem. All right, so let me check my notes, and I want to check the time. Okay, so let's talk about two cameras drawing the same object at the same time. And what I want to do is I'm just going to move everything up. Nah, never mind. I'm not going to do that. Instead, I'm just going to make the terrain disappear. I don't want the terrain to be there. That's why I got rid of that. Okay, so what we have is we have the same two cameras. I just undid that. All I did is I just made the terrain go away. Disabled it, so we don't have to see it right now. And I'll run this, and you'll see we just see the one box. And why is the light not hitting that box? Where's my light at? Let me adjust my light so it's hitting that box. There we go. Okay, so now the light is hitting the box. Fantastic. I didn't want it to be all grayed out. So we have these two cameras. All right, so what I want to do is I want both the cameras to draw at the same time. All right, and this is fairly simple to do. All I need to do is adjust whichever camera is drawing over the other one. So we have this camera here. All right, this is the first camera we had in our scene. It's a depth of -1. And we have this camera here, the second camera out of the scene, also with a depth of -1. But what happens if I adjust this clear flag? Because remember, what's happening is anything, any ray or line this camera's sending out that's not hitting this cube is being replaced with skybox. What if I changed this to depth only? All right, so it only drew the depth. Okay, and then I run this. All of a sudden, I see both. All right, this is the square that camera 1 is showing me, and this is the square that camera 2 is showing me. Camera 1 is drawing the blue screen and the cube, and camera 2 is just drawing the cube. It's not drawing anything out here, and as such, it's not overwriting what camera 1 sees. All right, and if you don't believe me, I'll prove it to you. This is the same cube, because if I click it while running the scene, you can see that it is in fact the same cube. Okay, so it's not parlor tricks, that's actually happening. Now, the fact that we're able to see the same cube with two different cameras, I mean, it's neat, it's a cool little trick, but at the same time, that's not really super useful, right? And really, I kind of did something I shouldn't have. If you're going to do stuff like that, just also change your depth on the second camera to 0. The reason that's important is you never know if Unity is going to forget which one was the second camera added, right? So if I set that one to 0, all of a sudden we're going to lose the effect, right? Because this camera is drawing after this one, and this camera, the first camera, is not clearing on depth only, it's clearing everything, and so we kind of lose our effect. And I think even if I switch back now, it's still going to do that. No, it's going to show both. Okay, fantastic. So it does keep track of when they were added to the scene, but who knows if there might be a glitch or a weirdness where it forgets which one was added first or whatever, right? Or maybe if you close it and reopen it. So we don't want to do that. We always want to make sure that the camera that's on bottom, right, the one that's supposed to be the first one drawn. Remember, it's like a stack, right? Like a stack of chips or whatever. The first one drawn is on the bottom. So the one that's on the bottom should have the lowest number. Okay, since I want this camera here to be the first one drawn, I use -1. This camera then, being the second one, should be 0. And now I can't possibly have any issues about when they were ordered or brought in or tracking or anything like that. All right. Cool. So what else can I do with this really, right? I mean, that's a neat little trick, but that's really kind of all it is, a trick, right? So let's talk about split screen, right? With split screen, we're talking about things like multiplayer and whatever. Basically, split screen. There's a ton of different ways we can do this, all right? So I'm going to go ahead and a couple things. My second camera here, I'm going to change it back to skybox, okay? I'm going to put it back to a -1 depth because with split screen, they can be drawn at the same time. They're going to occupy completely different versions of my screen. And I want to bring my terrain back. Come back, terrain. We missed you. Fantastic. Okay, so now effectively what I want to do is I want both of the cameras to draw everything they have, right, but I only want them to take up a portion of the viewport. You all remember viewport, right? Uh-oh. Looks like we do actually have a scammer, or spammer. Goodbye. Banned. That's fun. It's fun banning people. I've never got a chance to do that. Please don't post links to weird stuff. Not interested. Totally lost my train of thought. Sorry about that. Oh, we want both cameras to render everything we have, but we don't want them to overlap each other at all. We want them to share the viewport. And if you remember, the viewport is the portion of the screen that's normalized, goes from 0 to 1. All right, so let's walk through how this is going to work. So with my base camera, we're going to say my first camera, I want this to be on the top of my split screen. All right, and what I'm going to do is where it says normalized viewport rect, I want this to go completely across the screen, but only halfway down, like a horizontal split screen. So what I'm going to do is I'm going to start it in 0, 0, the upper left hand corner. I'm going to go to 1 for my width, right? That's the whole width of the screen, but I'm only going to go to 0.5 for the height. All right, so it's going to look like that. And for this camera, camera 2, I'm not going to start it at 0, 0. I'm going to start it at 0.5, and it's going to be 1 wide, but only 0.5 tall. All right, so now they're effectively sharing. The first camera is going to go 0, 0 to 0.51, and the second camera is going to go 0.5 to 1, 1. And when I run my scene, I get a nice split screen effect. Okay, two cameras sees the same thing, but from different perspectives. And if, let's pretend each of those cameras was a different character controller, player 1 and player 2, all of a sudden I have a split screen game. All right, just like that. That's really what it is. We're just sharing the screen, right? We're just drawing the two different viewports. Okay, and that's why normalized viewport rectangles are important. That's why I covered it earlier. All right. So that's our split screen effect. I'm not going to spend more time on that because I'm trying to hurry up so we can get to some other cool stuff. But this is being recorded, so you can always go back and see that. So let's talk about picture-in-picture now. And picture-in-picture is like, maybe say you had a mini-map, or you wanted to pop up someone else's view on your screen, or anything like that. Anytime you're going to have one base camera and then another camera showing you something cool in a corner or in the middle or on the side or whatever. So let's talk about how we would set that up. So the first thing is I'm going to come back to my first camera here, and I'm going to go back to my basic viewport of showing everything. 0, 0 to 1, 1, a depth of -1. This is going to be my base. This is what we're going to see. This camera here now is not going to compete with space for the first camera. It's just going to draw right on top of it. We're going to limit how much it can do that. So we're going to change its depth to 0 because we absolutely want it to draw on top of the other one. And we're going to put its starting X at 0.75, which will be 3/4 of the way across the screen. And we're going to start at 0, so it's going to be at the top. And then the width, let's say something like 0.2, and for a height, 0.2. Right? So just real small. And now when I run this, what I get is oh, I'm sorry, I was on the wrong size there. What I get is this, oh, am I reversed about my coordinates? Maybe 0, 0 is lower left-hand corner, not upper left-hand corner. Anyway, I might be backwards on that. I'm used to doing some other 2D programming where things are flipped. At any rate, you can play around with it and get it where you want. But you can see the effect now. We just have this little picture-in-picture down here at the bottom. And that could be a map. That could be anything. All right, we can do all sorts of neat stuff. Actually, someone in the chat just mentioned a custom GUI. I'm going to show you how to do that. Actually, we're going to be able to build custom GUIs using game objects with cameras. So I'm going to show you how to do that. It won't be fully functional or featured or anything like that, but I'll show you the gist. So this is our picture-in-picture, and we can pop this up. I mean, really, popping it up and turning it off, even while the game is running, is just a matter of enabling, disabling the camera, right? So as we're playing and someone pops up with a message, hey, you know, and then they go away, right? That's a very simple way that we can do that, right? It's pretty straightforward. Okay. So that's our picture-in-picture effect there. All right. So let me go ahead and readjust everything again back to normal. I'm going to put this back at -1. I'm going to put this at 0, 0, and 1, 1. There we go. So now, again, they're competing for the same space. I just like to reset everything back to the basics before I move on, in case I forget something and everything goes kind of weird. So we talked about split screening. We talked about picture-in-picture. Let's see here. Okay, so one other thing here. Let's talk about when some things only draw some things. Remember when I talked about the calling mask? Let me show you how to use that. So what I have here is I have this one cube, but what I'm going to do is I'm going to make it so this camera draws this cube, and this camera is actually going to draw a sphere. So let me create other sphere, and where's my cube at? My cube is at 59, 32, 86. So this is going to be at 61, 32, and I said 6. Wait a minute. 59, 32, 86. Sphere 61, 32, 86. Did I go in the wrong way? Oh, everything's backwards. Basically, I just want to make sure this will see the cube, or the sphere, and this will see the cube. Alright. So again, if I run this, we're only going to see the sphere because our second camera is overriding the first camera, right? So let's talk about how we can use two different objects, two different cameras with the same viewport space. Alright, so that we can effectively duplicate or create more objects than we think we have, right? And actually, to do this, what I want to do is let's bring these a little bit closer together. I just want this camera to be able to see that sphere. Okay, we'll do something like that. That works. I just want there to be some differentiation, but I want them to both be able to see everything. So let's check this out. So what I want to do is I'm going to make it so that this camera here, my second camera, first off, doesn't clear the skybox or solid color. So I'm going to set that to depth only, and I'm also going to set it to 0 for my depth, so it'll render on top of the other one. So you see how the screen kind of went away there. All right. And as a matter of fact, I'm going to make the terrain go away as well, because the terrain is going to make this go a little weird, because it's going to be rendered, and we can make that not happen. Or actually, no, I can turn this back on. I'm sorry, I'm getting ahead of myself. So basically, this is set to depth only, and this is set to a depth of 0. This has all the default settings, all right? So check this out. So what I'm going to do is I'm going to put my sphere on a custom layer. We talked about layers a while ago, so we're actually going to use them now. So I have my sphere selected, and I'm going to go to layer, and we have these layers built in, but I don't really want to use any of those. Instead, I'm going to add a new layer, so I'm going to click add layer, and for a user layer, I'm just going to say, I'm going to call it special, and I don't really care, it's just a generic name. So I create one that was called special, and I'm going to click the sphere again, and this time I'm going to go to layer, and I'm going to choose special. Okay, so far so good, anything crazy there. But let's come back to my camera now, and let's say, hey camera, go to your calling mask, and I'm going to say nothing, and then I'm going to say special. So my camera only draws special, right? Anything that's on the special layer. Since there's only one thing on the special layer, the sphere, we can see that it only draws the sphere. So let's run our scene and see what happens. All of a sudden I have two spheres, don't I? All right? I have two spheres in a cube. I don't really have two spheres in a cube. I have one sphere in one cube, but my second camera only sees the sphere and is drawing it to the screen, right? So it looks like I have two. These are actually the same sphere, two cameras, same viewport. It's a little crazy. So we can duplicate objects on screen using specialized layers and things like that. Let's take this a step further. Let's say that this camera just will draw everything but that special layer. So I'm going to come over here to my calling mask for this camera, and I'm just going to uncheck special. Now this camera just can't see the sphere. And so now what we have is we have a cube and a sphere, all right? And what's neat is that I can move the sphere by moving the camera, all right? And basically they can only see their own special objects. So this camera can only see the sphere, can't see anything else, and this camera can see everything but the sphere. Okay, so we can achieve some pretty neat effects that way. All right, so that's a pretty slick effect, and in and of itself, that is only moderately useful. The reason that's important is because at this point we can use that to build a custom GUI. So consider this. What I'm going to do is I'm going to take this second camera, and I'm going to rotate it to face the other way. I guess I can just rotate it a rotation of 0. All right, so I'm getting a rotation of 0, and I'm going to make it orthographic. And I'm going to make its size like 6. And now check this out. So what I want to do is, let's say that's 55, 33, 92. We'll make this the same. 55, 33, 92. Puts it kind of in the same spot. And then I'm going to move it out a bit. So can we see that? We can. And I'm going to make the size even smaller. So let's pretend. Oops. Let's pretend this sphere was a graphical user interface object, right? It was a mini-map, or it was a player's health, or it was anything along those lines, right? That these spheres are anything. We can put any textures we want on them. We can do text renderers. We can do anything we want. Words, whatever. You get the idea. I can put anything there. I can put animations, models, anything I want. And I'm just going to leave it like that. So it's orthographic, and I'm going to put all of these spheres. We have it on special layer. I'm going to rename it so we get the idea. I could leave it just like that, but I'm going to call this layer GUI. Okay? And I'm going to come here and put all of these spheres on the GUI layer. And I'm going to make this camera see everything but the GUI. Now, that's not super important because all this stuff is over here, and realistically, if I was making this game, this camera and these spheres and everything would be like way off in the distance, right? So that there would be no possibility of this issue, right? Or it would be below the surface, or it would be, you know, somewhere else where they wouldn't get in each other's way. But the idea is that we make this camera only see the GUI, so the things that happen in the game will never be drawn to the GUI, and we make this camera see everything but the GUI, so no matter which way we look, we can't accidentally see the GUI, right? And so now when I run my scene, I have a, oops, what'd I do? This camera is set to depth only. It's calling my, oh, it's not set to draw my GUI. So GUI, there we go. So now I run my scene, and now I have my game, and I also have my HUD. And to kind of really emphasize this, what I'm going to do is this camera here, I'm going to disable. And I'm going to come down here to my character controllers. These exist from the last time I ran this. I'm just going to drag a first-person character controller into my game. All right? And that's all I'm going to do. And I'm going to run my scene. And all of a sudden, I have my HUD. Okay? So, and it's following me around and it's showing me stuff. Now, notice how I can see that up there. Whoops. That's not supposed to happen. And the reason is because that first-person character controller is set to draw everything on the camera. And now I'm going to turn off GUI. Okay, and now I run it, and I can no longer see those objects floating up there in the screen. All right. So the question is it possible to use a GUI and an ortho camera from a separate scene rather than having the GUI in the current scene? No. I'm going to say no. Someone might know of a way, but basically the scene is the scene, and every scene is kind of an island, and they don't share. So if you could create your GUI and all that in one scene and have a do not destroy on load tag, right? And then load this scene, and those objects will be pulled into this scene, but they will be in this scene. There's no way. There's no way to cross over. Another question that just popped up is, anyone know where this other chat is? So if you're on Twitch, actually on the Unity page, unity3d.com/live learning, we're hosting the video there, and there's a chat room there. So some people are on Twitch, some people are on our chat role service on our page, and you're not seeing each other. So I apologize, but there's two. So yeah, another question: can you show how to rotate the camera? Rotating the camera is simple. You just let me get rid of the first part. Well, I'll just disable it. Goodbye. Rotating the camera is really just rotating the camera. It's just like any other game object. Now, if you mean how to rotate the camera in code, we're not in code yet, so I'm going to skip that. We'll get back to that. But basically, it's just like any other game object. It can just be rotated. With the first-person controller, the camera rotates automatically with the mouse. It just moves the mouse around, and I look like it was a first-person game. All right? Okay. So let's see here. So I talked about that, and we talked about how we can create a HUD. So that's kind of the neat part, is you do this, and I know it looks silly because they're just spheres, but use your imagination. Those spheres can be anything, right? They can be text, they can be animations, they can be models, they can be rainbows, they can be anything, right? And that's kind of neat, right? We can do kind of anything we want. And so there's a lot of power there. So you can use the built-in GUI system, but if you want to make your own, you can. And you can use all of the power of the Unity 3D engine, particle effects, and all this stuff. All you do is just keep your layers separate, okay? That's like the most important part. Yeah. So someone in chat is saying I'm attempting to post links. You can't post links. Please don't try. We don't want people posting links. I appreciate that you're trying to post links for the Unity page, but I'll pull it up here in a second. But or here, I'll type it in the chat. It's just unity3d.com /learn, and then just go to the live training. And I'll put that in here too. Unity3d.com. Oh, can't type. /learn. So you go there and click the live training, and yeah, no problem. Thanks for trying to post the link, but we just have that disabled to prevent abuse. But yeah, so you can go there. You can see the recorded videos. You can see the live sessions. You can see all that stuff. It's there. Okay, so I want to kind of speed up here because there's one more thing I want to talk about that I said that I was going to talk about previously, and we're running out of time, and that's rendered textures, because rendered textures are like super awesome. Okay, so let's do this. Let me get rid of all of this stuff. So all of these things that I've added, I'm just going to start deleting. Goodbye, 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 goodbye. So I have the terrain. I still have my first-person character controller, which I'm going to bring back. Boom. And I have my directional light. And those are the only things in my scene. And I'm actually going to rotate this guy around. So we start off seeing the island. Everything should be functional. Everything's good. All right, great. So now check this out. This is really cool. What I'm going to do is, for this camera, for my main camera, all right, I'm going to create another camera. Okay, so I'm going to do game object create other camera, and I'm going to just put it on the main camera. All right, so it's nested under there, and I'm going to set it to 0, 0, 0 and a rotation of 0, 0, 0. So that camera and this camera are aligned. Once they're aligned, now I'm going to take some liberties, and I'm going to move it up a little bit, and I'm going to circle it down so we get this top-down view of the player. And let me just come like way up, eagle bird's eye view, something like that. And actually, you know what? That's kind of boring. Let me also bring it forward just a little bit. There we go. So, okay, I got a question. When using game objects like that as GUI, how does one then make them clickable? Special mouse listener to record the clicks. So you can do something like a mouse listener, just on mouse down should recognize it because it just raycasts from the camera, right? And since the camera's being picked up by a camera, or the GUI's being picked up by a camera, it should work. I haven't done it in a while. I believe that's how I did it last time. I might be completely wrong, but off the top of my head, I'm pretty sure that's how I did it. I think you just click on it, right? And use the void on mouse down function. But that's, again, getting into scripting and something I kind of don't want to talk about right now, but it's achievable through scripting, kind of like how I just described. Okay, so I have this camera, I have this new camera. This camera is automatically set to a depth of 0, so that's fine. But I don't want to draw, so if I run this right now, this is what I get. Oh, wait a minute, why did only one draw? Oh, because that one's also set to 0. Let's set that one to -1. There we go. So this is what I get right now, and that's kind of right? So what I want to do is I don't want this camera to draw to my screen. I want it to draw to something else, right? So what I'm going to do is I'm going to come up here, and I'm going to create a plane. Create other plane. Why can't I find it? There we go. And that plane we're going to rotate up, rotate it sideways. It's this big plane in the sky. And let me take this new camera just for a second. I'm going to disable it, and I'm going to hit play. I just want to make sure I can see that plane. Yeah, that's pretty reasonable. I'm going to rotate it down just a little bit. I'm going to scale it to be a little bit wider. Great. So I have this plane up in the sky. And now what I'm going to do is I'm actually going to project that second camera onto that plane, right? So it's going to be like a jumbotron, right? And the jumbotron is like sports. So if we had cameras following different players, we could project them on the jumbotron. Think of it like a racing game where you drive through the runway or fairway, whatever you call it in driving, or the road, I don't know, straight part. And you see the jumbotron that shows you some of the cars that are driving. That's what we're going to create right now. So what I'm going to do in assets in my project view is I'm going to right click, I'm going to go to create, and I'm going to select render texture. Now again, this is a pro only feature, but I think it's awesome, so I'm going to show it to you. And I'm going to call it Jumbotron. There we go, Jumbotron. And Jumbotron has its size here, so I'm going to make it, I don't know, 512 by 512. There'll be some stretching there. Let's actually make it 1024 by 512. And we have our wrap mode, which is clamp, our Anzio level, which will be the quality. Won't let me upgrade that. Maybe it's due to my quality settings. The depth buffer and things like that. We're pretty much going to leave that alone, but I'm going to set it to 1024 512. And I'm going to take the Jumbotron texture and I'm going to put it on the Jumbotron plane, so it turns black. All right, just like that. All right, and then what I'm going to do is here I'm going to find the camera that I disabled. I'm going to re-enable it, but down here where it says target texture, I am now going to choose Jumbotron. All right, so now we're not going to draw this to the screen. We're going to draw it to our Jumbotron. And when I hit play, up in the sky, I have a Jumbotron showing me my progress. All right, just like that. And as I'm watching it, it's watching me. Right? I can put any camera I want on there. As a matter of fact, if I were to say main camera here, like let's disable that camera. Let's go to my main camera, and let's instead of the screen, let's make my main camera go to the Jumbotron. I have no idea what's going to happen. Oh, I gotta have, yeah, this other camera I'm going to enable and also set to maybe -1. I'm not going to be able to make this work. I just think about that. If my main camera is projected on here, we can see what it looks like, just like that, how we get this infinite picture in picture in picture, but we basically need a base texture. So yeah, let's forget I was trying to do that because I'm just screwing it up. So this second camera, let me go back to 0, and this camera that's on the first person controller, let me get rid of that Jumbotron texture. There we go. Make sure everything's working again. Great. So here's one last super cool thing. All right. Yeah, one last super cool thing. I know I'm way over time here, especially with our technical blip, but I want to do one more thing here. And what I want to do is I am going to take this camera right here, the new one that we added that looks down, and I'm going to drag it and put it on top of the plane. All right. And I'm going to set it to 0, 0, 0 with a rotation of 0, 0, 0. Okay. Just like that. And what I want to do is I'm going to bring it up. And it's due to the rotation of the plane, it's actually upside down. Something like this. And let's simplify that. Let's make that. So at 0, 0, 0, we want it to be along the x-axis 90 degrees, and then along the z-axis 180. Fantastic. So it's perfectly flat. So check this out. So that's what we get. We get projected onto the screen whatever is behind the screen. All right. And so now if I run my game, I get this weird like kind of transparency thing, right? It depends on how you're lined up, but effectively what this enables us to do is to create this weird like Predator style camouflage system, right? So if I run my game, and all of a sudden projected on the front is what's on the back. Hopefully I can get up the hill, right? And so if I were to move the plane left and right, then all of a sudden the texture that was on the plane would also move, right? And as such, it would seem like the texture was see-through, all right? Because it would, as the plane moved, what was on the plane would also move, and we wouldn't be able to see it, right? This happens to be kind of a, yeah, it's bad right now because my camera is so much lower than it, and the plane itself is not moving. However, if the plane was moving, it would be a highly effective camouflage, right? Because it would pan and move kind of and look crazy. Originally, I wanted to do it with a cube in a very controlled environment, but I'm running out of time, so this is my makeshift camo system. It's still better than no camo, but yeah, it's not fantastic. But anyway, so that is some of the stuff we can do with rendered textures, and we can stack a render texture on a render texture on a render texture to create this like layered camo system. We can do all sorts of stuff with it, really. But the idea is that just the camera is projecting onto that texture. Okay, so I have gone over quite significantly. Let's see what time it is. Yes, I've gone over by a bit. I like to keep these things to about an hour, and so I'm going to go ahead and wrap up now. So just kind of cover what I've talked about so far. This was all about cameras. Originally I mentioned possibly going over lights, but I can see now that I had not enough time. There's even so much more that I'd like to cover. But we talked about cameras. We talked about how the camera is just a component. We talked about the spaces. We talked about world space, screen space, and viewport space. We talked about the camera properties. We talked about perspective versus orthographic cameras. We talked about multiple cameras and how how we choose how they draw, split screening, picture-in-picture. We talked about buffer clearing to be able to show multiple objects on a screen at the same time, or one object multiple times and things like that. And we talked about the rendered texture. So what we have next week is lights on Monday, but I'm also doing an intermediate demonstration on Wednesday, which is fun with lasers. So if you've ever wanted to shoot teddy bears with rainbow lasers, Wednesday is definitely one you're going to want to show up for. We will be using ray casting and line renderers to build laser guns. So that one should be pretty fun because I get requests for lasers a lot. Let me pull this back up here. Oh, by the way, the one on lasers next week is at a different time. So go to the live page. I linked it before. It's unity3d.com/learn. Go there and click the live training button and select or check out the fun with lasers. It's at noon my time, which will be completely different for you guys. I believe that's 5 o'clock GMT time, but just so you don't miss it. Again, you can reach us on Twitter with any questions or concerns or anything like that, at Unity3D, at Mike Geig, which is me, at Will Goldstone, and at the Ant Ranch. Yeah, so anyway, any questions you have, pass them along, any comments. Normally I like to stick around at the end for questions, but I do need to get going today, so I apologize. I won't be able to stick around for questions. Send them to me via Twitter or talks amongst yourselves, and hopefully you can get everything figured out. Otherwise, just always message me. More than happy to help out. Just reading through the chat here to make sure there's nothing else. Dan Stevie shoots bears every day with rainbows, so I guess it won't be anything new for you. Let's see here. Let me pull up that Unity 3D, and I'll just post the link. So you can come here. There's that, and where's that? Yeah, well, I'm actually at GMT -4 right now, but I will be at GMT -5 after the weekend for daylight savings time. So yeah, but anyway, that link will take you to the live training page, so check stuff out. The archive of this will be available there soon. I do need to get going. Thank you all for being present. If you have any questions, pass them along. I'll be more than happy to help out. And otherwise, have a fantastic week. Thanks very much.